And now, Hardy-Weinberg law. The Hardy-Weinberg states that the gene frequencies of various genes in a population remains constant generation after the generation when the population is in the large. So, in absence of mutation, any mutagenic change or selection and migration, it occurs. When the gene frequencies remains constant, generation after the generation, the population is in genetic equilibrium. When the population is in the genetic equilibrium, the rate of evolution is zero. When the population obeys the Hardy-Weinberg law, the population will not undergo any evolution. So, what we can conclude that evolution occurs only when the Hardy-Weinberg equilibrium is altered or a bit change in its, can say generally, in its equilibrium. So the Hardy-Weinberg's law, so called as a formula, or he has formulated as P plus Q is equal to 1. So this is an equation. According to this equation, Hardy-Weinberg's equation are the formula where the P is equal to the frequency of a dominant gene, and the Q stand for the frequency of a recessive genes, and when just the frequency of the dominant gene and the frequency of the frequency of recessive gene is almost to come 1. So, as per the statement P plus Q is 1, it is the law, the frequency of a heterozygous and homozygous in a population can be calculated by Hardy-Weinberg's formula. According to this formula, if we just say P plus Q stand for 1, the P plus Q, P square, when we take a square of it, P square plus 2PQ plus Q square, where the 2PQ stand for frequency of heterozygous and the Q stand for the frequency of the recessive homozygous. And now you can say the P is the frequency of a dominant gene and the Q stand for the frequency of a recessive gene. The P square is nothing but frequency of dominant and homozygous. So we are concluded the formula. Now let us speak significances, the importance of the Hardy-Weinberg's law and all that. According to this Hardy-Weinberg's principle or the Hardy-Weinberg's law, as we know the statement that the frequencies in large population, when we take the example of frequencies in the large population, that remains constant, there is no change at all. That's what it implies. The second thing is when population in equilibrium, no possibility for evolutionary change. So that means that it always population remains in equilibrium, in a state of equilibrium, and no possibility of evolutionary change. Now, third is it implicable when the equilibrium tends to gain the characters. The equilibrium tends to conserve the gain in characters. The fourth one, the equilibrium keeps a stores of recessive genes continuously in existence in population. or the equilibrium maintains a heterozygous or a heterozygosity, heterozygous zygotes in its population. That's all.